In this video, we're going to talk about linear transformations. A linear transformation is a function from one vector space to another that preserves vector addition and scalar multiplication. Let V and W represent vector spaces. If the following properties hold true for all U and V in vector space V, and for any scalar C, then we can say the function t from V to W is a linear transformation of V into W. Those properties are the preservation of vector addition, t of U plus V is equal to t of U plus t of V, and t of Cu is equal to C times T of U. We can say that T from V into W, in other words, a linear transformation of V into W, is a function that maps a vector space V into a vector space W. We call W the image of V under T if V is in vector space V and W is in vector space W, so that T of V is equal to W. The range of T is the set of all images of vectors in V. The pre-image of W is the set of all V in vector space V, such that T of V is equal to W. Let's look at an example. Suppose that T of V1, V2 is equal to V1 minus V2 plus 2 V2. Let's find the image of V equals the vector negative 1, positive 2. If V equals vector negative 1, 2, if we want the image of V, then we simply substitute negative 1 and 2 for V1 and V2 in our original statement. So we have negative 1 minus 2, and then for V1 plus 2 V2, we substitute our values, negative 1 plus 2 times positive 2. Simplifying our terms, we have negative 3, positive 3. And there's our result. Now let's find the pre-image of W when W is equal to negative 1, 11. If T of V is equal to V1 minus V2 and V1 plus 2V, now let's set this expression equal to negative 1, 11. We can solve for V1 and V2 using a system of equations where V1 minus V2 equals negative 1 and V sub 1 plus 2V equals 11. Now let's solve for each variable. I'll use the elimination method. So then I have V1 minus V2 equals negative 1. And now we solve by distributing a negative through the second equation. So that new equation reads negative V sub 1 minus 2v equals negative 11. These terms cancel out. You have negative 3v equals negative 12. So v is equal to positive 4. Using back substitution. I'm sorry, that was for v sub 2. So v sub 2 equals 4. We'll substitute it back into the first equation here. So we have v sub 1 minus 4 equals negative 1. We add 4 to both sides. So we have v sub 1 equals 3. Therefore, we can say that the preimage of vector negative 1, 11 is a set in R2 that contains the single vector 3, 4. So this concludes our example of a brief introduction to linear transformations. I hope you found it helpful, and we'll see you next time.